Hello, I'm Eric Snodgrass, and thank you for watching this Thursday night, February 9th, in-depth ag forecast brought to you by Nutrien Ag Solutions. Today I received several text messages and emails asking questions about how quickly the La Niña is going to fade and possibly transition to El Nino conditions. Also some questions about solar cycles and some questions about maybe what this upcoming summer might look like. And a big question, is 2012 an analog year for this year? So I'd like to address that. Let's just give it a good discussion here, okay? So we've been looking here at a graphic that I showed you on Monday night, and it looks at the Niña region 3.4, so that's right in the middle of the equatorial Pacific, at how fast the European ensemble, so all of these are different ensemble members, how fast it's predicting the return toward neutral conditions, which is between a ½ degree above and ½ degree below average. And then if there is a transition to El Nino, how quickly does that happen? And one of the main stories we've kind of carried with this is that more than likely the models are too aggressive when you look at them on returning El Nino conditions, some of them suggesting that by even early summer having that. So we need to know what that means. We need to understand what the transition years can signal, and then we also need to look at other sources of information. So new data just came out today, came from NOAA's CPC analysis. This comes from Columbia University, and we're going to look at their latest update here on the 9th. Now what's interesting is in their newest analysis, they included January here. But if we notice that from February, March, and April all the way to the April, May, June outlook, that the highest probabilities here, in fact, up to almost a 95% chance of having ENSO neutral conditions for our spring months, March, April, and May. Now, the big thing to think about is when you go to ENSO neutral, that means we've now lost the strong easterly winds and the trade winds. We've lost the westerly wind bursts out of the Indian Ocean, and therefore the MJO tends to move around quite a bit. That's really the big thing that happens here. This also means that there will likely be a change in the momentum of the atmosphere coming off the Pacific Ocean. All right, those are the big things. You then see that, unlike what the European model suggests, that we may be all the way out here until late summer and early fall before we finally start to see a true El Nino-like behavior in the atmosphere, where instead of having strong trade winds, we have strong weak trade winds, or none, or possibly even westerly winds that extend across the equatorial Pacific. That's what that all kind of means. So this is just the latest to talk about that transition. Now, we've been watching these ocean temperatures for a while, and we've now seen that despite the cooler anomalies that are still here in Niña region 3.4 over the last month and a half, we've seen a lot of warm water returning over here to just off South America. And there's a lot of warm water compared to normal under this that could very well begin to slosh back and surface. And that would really signal kind of the demise of this La Niña. Now, the appearance of warm water doesn't mean that the atmosphere is behaving like El Nino yet. Okay, that's just the slosh back. What we have to see to get a really strong El Nino is, to be honest with you, these trade winds have to start showing some sort of a component from the west. And we may not see that, like I said, until we get into late summer or fall. But the fact that El Nino is possibly coming later, and that La Niña is coming off the table quickly, is going to influence the spring forecast in a big way. So we know that the major models by this is May, June, July, are already trying to bring back, we just kind of look in this corridor right into here, sorry. We see the warmer water. This is not only in the ECMWF, but in the newly released National Multi-Model Forecast. Little different projection, a different view, but you see very similar components, right? There's warm water here and warm water there. So both of these things. Now, this warm signal would give us some clue about possibly seeing El Nino-like behavior. But it's a bit interesting to see that there would be El Nino behavior while we still have warm water between Alaska and Hawaii. So this would be our negative PDO signal. So let's talk about both of these, because in several videos over the last month or two, I've talked about how this would be a competing factor for the central United States precipitation pattern. This is a wetter signal and this is a drier signal. All right, so we need to have that discussion because it's in both models. So let's get into all of this. All right, first, transition speed. When looking back to 1990 at the Oceanic Niño Index, ONI, we're looking here at those time periods where we've come out of these negative ONI values to positive. So think about 95, 96, and then going into the very, very strong El Nino that was in 97, 98. Now you notice that coming out of 1996 into spring of 97, it took almost all the way until we got fully into midsummer and then beyond that we would say that we'd made a full transition. And that was one of the biggest. It took even a little bit longer when we came out of the 10, 11, 11, 12 time period of La Nina to get into the 15, 16 El Nino. And I know that there's a lot of folks out there possibly just curious about or concerned if the current La Nina event has any sort of similarities to what we came out of in 10, 11, 11, 12. And overall, my short answer is this was a much different La Nina in its kind of in the total package, how long it lasted and how cold the ocean temperatures were. So I don't see a lot of similarities at this point between these years. And I'm going to explain that a bit further in just a few seconds. So take a quick snapshot of this in your head and understand that it often takes 6 to 9 months to fully make a change away from one phase to the next. Now, talking about ocean temperatures, and because I was specifically asked about 2012, this is what the ocean temperatures look like on February 9th, 2012. So yeah, we were starting to see some warmer water surface here, but that La Nina event was much stronger. And the depth of the cool water by the Baja of California and into the Gulf of Alaska all the way over to Japan was a much stronger negative PDO signal. Now, if I go all the way to July 9th, 2012, what was very important is, sure, we saw La Nina fade and a lot of warm water come here. But the very cold ocean temperatures that went right through this area, that's a part of a very dominant negative PDO signal, meant that the risk of having a large sector of the mid part of the country develop drought was very, very high. This is a very strong signal. La Nina is not the most important signal for U.S. precipitation in summer. It has a lot to do with the North Pacific. So I'd like to show you something. This again is February 9th, 2012. And what we had back here is what we currently have, February 8th, 2023. So the most important thing to watch is the warm water here and if we can get cold water to surround this. And right now we do not see that as a signal in the longer range models. So this is one of the reasons why I pulled 2012 out of the analog package when I'm looking out this far. I don't quite see that dominant signal at this point. So I can't say that 2012 is a strong analog. Plus, yes, the PDO has been negative. It was very negative last year and the year before. But as we come into right now, its January value was minus 1.28. And in January of 2012, if we get there, it was way down there, December, January, it was like minus 2.4, and it even got lower again as we went through the summer, almost down to minus 3. So that was one of the stronger negative PDO events that we have seen. So that's why I just don't see that strong of a correlation at this point. But there was another question in some of these emails about, are we getting close to the end of an 89-year cycle in drought? I just want to reiterate something about this. I've studied this particular issue. I've looked at every drought indicator from the Palmer Drought Severity Index to actual precipitation records from NOAA, and I cannot reproduce any sort of an 89-year drought cycle that has statistical significance. I feel as though there's some coincidence in some of the drought, like the 1847 drought, the 1936 drought, and then of course there's, if you just add another 90 years to that, you end up getting, or 89 years, you end up getting 2025. But statistically, which is what I'll rely on, there is no strong signal that comes out. So I cannot use the Gleissburg cycles as a drought indicator to predict what's upcoming. I just can't do that based upon what I've found. I did a peer review literature search on this, and in all the atmospheric science journals that I'm familiar with and use, there are actually articles about how the 89-year drought cycle, the 89-year Gleissburg cycle is not strongly correlated with drought. It's more driven, drought is more driven by the ocean temperature pattern in the Pacific than it is by this. So I just want to reiterate that fact. Just to make a point on it, I can correlate, you can do this with NOAA's tools, you can correlate the April to October precipitation against the solar index, which is looking at that, the number of sunspots. That's the sunspot cycle stuff you see here. And I just want to make a point here. When you look at it, you see positive correlations. In other words, it's wetter when there's more sunspots and drier when there's fewer. Okay, that's what you're getting here. But I'd like to make a point that the color shading you see on this graphic is staying between about, well, minus 0.25 to plus 0.25. And just as a quick reminder about correlation maps mean, is that for every single one of these climate reporting districts, the correlation coefficients over the last, well, from 48 to 2020, this is what a correlation coefficient of 0.25 looks like. So any given year looks like a shotgun blast on a scatter plot, and you cannot use that, therefore, as a predictor. So I need to be very careful with that narrative, just to let you know that I'm not using the 89-year drought cycle. I'm not using solar as a predictor, and I don't think that the transition out of La Niña looks like it did during some of our major drought years. That's my story at this point. Now, what do we know? Well, if you go back and reconstruct April to May soil moisture, or the Palmer Drought Severity Index, and you put in some very dry years for the midsection of the country, all right, what you find is that 1288, you can see the years I've got listed here, that from North Dakota to Texas, and from, you know, the high Western Plains all the way to West Virginia and Pennsylvania, there was very dry soil to begin with. And that is a predictor. If you've got dry soil in place and it's not rectified in spring, April to May, then drought risk increases for the big crops that are grown in the midsection of the United States, this whole area and through here. The other component is ocean temperatures, and these are, again, more symptomatic of what the atmosphere is doing. So I used the same years, got them down here, and you stitch them all together, make a composite, and there was La Niña, there was cold water off the Baja, cold water in the Gulf of Alaska, and very warm water tucked in between. That is a very negative PDO cycle, signal at the same time when there is La Niña. So here we are. I'm telling you that the models are attempting to get rid of La Niña. There's still warm water here, but not the cold water signal along the coast. That's one component off the table. And are we currently dry in this area? Absolutely. This is the newest drought monitor released today. There's long-standing drought issues in this area. And I've made a case and been telling, you know, in these videos that there is still lingering drought from last fall that still sits under all that snow, that sits under some of the recent rain down there at 40 inches. But it's February, and this map that I just showed you here, this is April and May, which means if we don't see corrective action on the soil moisture anomalies by that time period, April to May, then the drought risk does increase. But it does not appear that we're going to have the second component of it, which is the ocean temperature pattern looking like those really drought-stricken years. So I hope that provides some clarity with all of this. And the main story is, we really wouldn't be able to make a call on the risk of summer drought until we see what spring rain delivers. Okay? That's the big picture here. So let's talk about some other components to this. We did recently have some snow. Today, some very heavy, big snowflakes ripped through this area. Some places picking up 3 to 5 inches of snow. This is just the last 6 hours through this afternoon. And then before that, of course, this was in parts of Missouri and Kansas, right in through here in southern Iowa. So we just added some more snow to that area. But when you look, let's blow this up so you can see it. There you go. This is currently where we've got snow on the ground. And again, this is the latest map for the snow water equivalent. So this does not include what just came in here. Now, there are some places here, the Red River Valley of the North, parts of South Dakota, even though it's melting in this area, but Minnesota, Wisconsin, where this whole region has some places between 2 and 6 inches of liquid in it. There are still major snow deficits, though, back on the headwaters of the Missouri River, as an example. But this could help, as it melts, get and revive some of that profile. Now, just to take a look at the west, the color bar is a bit it's hard to decipher here, so I just want to show you the latest update on what things look like out in the west. One area that desperately needs more snow is the Cascades, the northern Rockies. We need to build up more snowpack here. But still, after what you saw back in January, the amounts are still very high all the way to the upper Colorado Basin, which currently has about 128% of average snowpack on top of it. So we're still looking at decent snows here. And we're going to talk in a minute about how I think there's going to be a better pattern at the end of this month into March to delivering more precipitation here. From there, I just want to reiterate one last thing. If we're thinking about spring's potential for eliminating that other drought risk variable, the lack of soil moisture. We do know that the latest update, which we showed earlier this week from the NMME, do have this area seeing near normal to above normal precipitation, especially wet down here in the Ohio River Valley. It's trying to keep the driest conditions in the high plains and along the Gulf Coast. And you can see in Southern California, the model is not aggressively returning decent moisture. But this is a good signal for the Northwest. In terms of temperatures, the model's still very much hung up on this pattern of cold air being delivered through the Canadian prairie and colder across the west, but also mild from Texas all the way through the eastern half of the United States. That same forecast was echoed by the newest update from the ECMWF, which we put in the reports earlier this week. It's very similar overall in their forecasts. So what I'm saying again is we got to get to April and May to see if spring rains can undo some of the longer standing subsurface soil moisture issues. If we eliminate that and we also see La Niña continue to fade, we just removed 2 large sources of drought for everywhere east of the Rocky Mountains. Now remember, west of the Rocky Mountains, once we get into April and May, that starts the dry season. And I am concerned that if the water temperatures remain very warm in this area, that we could see the return of ridging across the western United States going into summer of next year. And there is some model evidence to support that. But if we keep on track with this analysis, I want to show you that the La Niña is currently losing its stronghold on things. Notice that over the next 15 days, no longer do we see the big, deep, dark blues and greens representing those strong trades. And the westerly wind bursts are no longer as evident as well. So the MJO is allowed to move. And it's coming out of the Indian Ocean, sweeping north of Australia, and then it's eventually going to come over here into the West Pacific. And why this is important is that movement is a part of the teleconnections we'll be looking at to influence the weather patterns across North America. At this point, I think this is the more dominant of the teleconnections because I don't see any high latitude blocking over Greenland, over Scandinavia, or over Alaska, or over the Arctic. So this is what I want you to see. Toward the end of this month, as we sweep quickly through phase 5 and 6, if we do end up in phase 7 and 8, we know a couple of things about that. I decided to pick the ENSO neutral version of these, MJO phase 7. Now what's important about it is this would actually represent better troughing coming through the Aleutian Islands in Alaska. That's better flow into the west. Ridging in this area doesn't mean dry. It just means that flow's got to make the turn like we've been seeing for the last few weeks. And this overall is a very wet pattern from the west to the Midwest. This is not dry. What this doesn't do is this doesn't produce any big East Coast cyclones. This is the wrong setup for that. That's MJO phase 7 where we'll go first. Now MJO phase 8 in February really extends the Pacific jet again. And if we do get a true teleconnection with MJO phase 8, this will push the better chances of a late February, early March, well, miracle March for the West. And this is also not a dry signal and could potentially be one that finally returns a lot of larger systems up the East Coast. Could. There's just potential in it. And if we get into March, phase 8, in other words, we start March with phase 8, again, extended Pacific jet, it's going to run right up in through this area. I don't like this high over low look, but if we do get that, Texas gets the moisture. So there's a lot going on with this pattern changing. And the loss of La Niña means we're going to have to look at these subseasonal factors to start to take over. I do want to point out that the new CFSV2 for week 3 is finally starting to try to return at the end of the month better moisture into California. Instead of keeping a big bullseye of dry weather over here, it has backed that off, but very wet across other locations. So you can start to see some of this happening at the end of the month. Okay, one last thing to look at, and then we'll get into the near term. I do not buy into this forecast from the end of February through March 25th for the western United States. I think it's actually too dry. Based off of what I think the MJO is going to do, I think this is a bit deceiving. I think the model was initialized dry in the west, and it carried that bias going forward. Because right now it is dry in the west, drier than normal. So again, I don't fully buy it. I do think that this corridor, and that corridor will be active for storm systems. In other words, you'll see low pressure systems tracking like the arrows I saw. And as a result, I wonder if we're going to actually see drier conditions in Texas as advertised here. So that's kind of my outlook at this point going through March. Let's quickly flip it over to temperatures and look at that 30-day time period. The model went aggressively colder, and I have to just put a big question mark on this for how long we could see colder air coming through in March into the northern plains, and will it make it down all the way to the Gulf of Mexico and the East Coast. If we do get into a full MJO phase 8, sure, I think we'll see that. But we've still got several warm weeks to go before we get into this kind of pattern. So just want to leave it there so we've seen it. We're going to continue to analyze it over the next several videos. Right now, we're watching the tail end of some very windy conditions throughout the Midwest going over the Great Lakes. This is very windy in this area today. And there's a front that's dipped pretty far to the south. But what I'm interested in is what's happening in New Mexico right now. So let's talk about the near-term weather, because I stepped this up to 500 millibars, and this is going to be a very interesting shortwave. We're going to watch dipping down and running over that subtropical ridge we've talked so much about. So that shortwave that's through there is going to do something like this. Here it is this evening, getting into tomorrow morning. And the models right now are cutting it off, which means the flow is going to zip over the top of it, allowing it to close a low. It's now deeper, farther to the south over Louisiana by Saturday evening. And then it is now farther south here over South Carolina versus North Carolina by Sunday night. Now, while that's happening, there's another cutoff low coming into California we're going to talk about in a second as well. But what this just did is this really increased the chances for snow all along the Appalachian Mountains. Eastern side of Tennessee, Kentucky, parts of West Virginia and Virginia, and then western North Carolina. So I want to show you that in just a few seconds. But then we followed up with a cutoff low that comes through California, and watch where that one goes. Dove in like this, and it's going to do that same thing. That quick check mark view goes right through the Red River, straight to Illinois, and eventually to the Great Lakes. And it's followed here next Wednesday by another one. See, that one dives down and does the same thing. So this is a very active pattern over the next 10 days. And let's start off by looking at the first one. So this evening on Thursday, one low is going to move into Ontario and Quebec, bringing some rain, cold rain here to parts of New England. But it's this guy right here I'm keeping my eye on, because that upper level wave is trying to move its way toward, there it is, see it? There's a possibility of getting some snow mixed in here on Friday afternoon and evening, and that low is going to begin to curl, see it? So what you're going to watch is, here's the upper level shortwave. This is the flow around the subtropical ridge. So this is now getting into Friday night and Saturday morning, and watch this wave open up over the south. And I'll just be honest, the model's trying to stay cool enough to get some snow into central Mississippi. We'll watch for that. But then this system rolls right up here. There could be some cold air damming up against the mountains and the risk for some ice. And then you see the flip over in northern Alabama, Georgia, getting into Tennessee, Kentucky, over to snow. Now, this model only runs out 60 hours, so we got to flip over to our multi-model analysis. This is the GFS and the European to see where it goes. So we've already watched this system. That's the one that went through today. Notice it looks very similar Saturday morning to the previous run from the from the NAM. And watch that low come out, and there it goes. So while a cutoff sits just off California, that's the next big system. This one cut all the way down into Louisiana and has now run up through North Carolina and South Carolina. Very wet conditions here. Notice the models are attempting to put down snow. The GFS is trying to bring it to western North Carolina. The European's keeping it over the Appalachian Mountains. And then that one is going to quickly move offshore by Monday morning. Now, why doesn't it continue to run up the East Coast? The big problem is the high pressure that comes in behind it comes in too late. We would have needed to have this here on Saturday in order to help ensure that that low is going to go straight to the north. So it ends up running out to open ocean. Now, while all of that was going on, take note of the cutoff low coming through Southern California. That one then moves over, whoops, sorry, I went too far there, by next Monday over the Arizona and Mexico area as another deep trough cuts into the northwest. This is a snowmaker for the Cascades in the northern Rockies. In fact, it's a snowmaker for much of the Rockies. So here's the second one, or guess what, that'd be the third one. This one comes out of the Red River Valley of the south, Both models, this is next Tuesday morning, afternoon, and evening. There'll be another setup for storm south. It's going to produce heavy rains through the Midwest, curl its way north, and possibly bring some snow to northern Minnesota on the headwaters of the Mississippi. Now, the models do get out of sync in terms of their timing of this next one, though. It's right now sitting in the Four Corner States delivering snow to the Rockies. I'll show you how much in just a second. But that one comes out and maybe has enough cold air to work with And it depends on which model you're looking at here. The GFS ejects much farther to the north, so it's snow from Colorado, Kansas, Nebraska, South Dakota, Minnesota, Iowa. Look at where the European takes it: New Mexico, Texas, Oklahoma, Kansas, Colorado. And then it goes through parts of Missouri, Illinois, Iowa, Wisconsin, versus the snow swath here going much farther to the north. So when I said this pattern's active, it's moving. There's a lot going on in this pattern, and I like it. I mean, it's good to see. To compare the models, remember on this particular map, these colors represent where the GFS is wetter. These are where the European is wetter. So remember, the GFS bringing the system farther to the north is wetter in the northern plains. The European's wetter in the southern plains through the Midwest. Same thing over here with the difference in the position of these systems. GFS wetter here, European wetter there. So let's start looking at a few different numbers. I'm going to stick with the European on this. This includes some of the snow today, so that's what's going on right here. But as we play this forward, you now notice that the European model is trying to hit the Appalachian Mountains right there where they transition from Tennessee to Kentucky, Tennessee to North Carolina with several inches possible. The model is actually trying to pick up between 6 and 18 inches in some places here. That's system number 1. Number 2, remember the cutoff through California? It now comes out right here, and as it rips north, it's trying to deliver some snow to northern Minnesota. That's system number 2, so watch up there. 3 comes in, deeper wave, snow in the Cascades, snow in the northern Rockies, but a lot of snow in the central Rockies where we need it. And then this one comes out and tries to follow this track, but there's enough cold air to work with that it's trying to put down some heavy snow from eastern Kansas all the way through Michigan, into Ontario, into Quebec. That's what we're looking at here. Now remember, that's pretty far out for an operational run to figure things out. So I'm going to show you, this is the map showing the probability of getting at least 3 inches of snow for the next 10 days. I step it up, this is the chances. Oops, sorry, got a new model run that just came in. Let's go back to the 12Z. I can take that out to 10 days. There we go. That is the probability of 6 inches over the next 10 days. So again, we're going to watch this corridor in through here and then into, of course, Ontario and Quebec and right in through there in the Appalachian Mountains. Here's the chance of 12 inches. So Cascades, Ontario, Quebec, that's where we're looking at this point. On the precipitation side of this, or the liquid side of this, let's flip it over here and go to probability of 1 inch. There you go. This is the probability of getting 2 inches. And wettest down here, and 4 inches. From there, let's go talk about week 2, because this pattern isn't slowing down and the models are finally losing the dry signal for the west. Wetter signal here and very wet into this area, and that's also echoed by the GFS. You see a very similar setup for week 2. I don't know why I call them this, but they're kind of like these checkmark systems. They kind of come down and they're doing something like this, or there's a cutoff low that then shoots up like that. Okay, finally, if we get out there, the CPC is in agreement with what we just talked about. This is their risk of colder air coming through with this pattern. This is the chances of having above normal precipitation. So late this month, the 17th to the 23rd, yep, we're keeping it wet in the mid-south and southeast. And now we can see the effect of that potential transition over toward phase 8, giving us wetter conditions in California. On the snow side of it, this is where they're predicting the risk of having some heavy snows out of these next few systems fully into week 2. And it is expected to be windy. Most of the country, whoops, sorry about that, seeing some form of having some higher winds. All right, to finish this all up, I want to make a comment about what's going on with the Great Lakes right now, because we did get a good view of them on February the 8th, some clear skies there, and you don't see much ice. In fact, right now, if we just take a look at this, I'm going to click here. Oh, sorry, got a new website. There we go. Only 10.5% of the Great Lakes have ice coverage on them. And compared to normal, I mean, I live near Lake Michigan, so I'll just show you Lake Michigan. This is where the current ice concentration is. And so you can see historically, it's been much higher this time of year. So that just is a concern to think about. That could be important for spring temperatures in the Great Lakes states on the eastern side of the Great Lakes. So like Indiana, Ohio, Michigan, Ontario, we're going to have to watch that. Also New York, Pennsylvania. Just want to make sure you're aware of that. And certainly over the next 15 days, the temperature stays mild. The coldest air anchors in the west, and we really try to see cold air come out of the Canadian prairie. but the latest European model forecast suggests that even out there to the third week, we keep this pattern in. And if you want to know why we see those, I don't know why I call them this, but the checkmark storms, they're just got to follow this temperature pattern. They got to do that. So that's the big picture idea here. Okay, one last thing tonight, and it is South America. I talked to 2 people that are there today, and I'll let you know that from Mato Grosso to Goiás, Sao Paulo, Paraná, and Minas Gerais, this area has seen a lot of flooding as of late. Very, very wet conditions. The crop is full, though, so they can take that water. But some of the wettest conditions some people down here say they've seen since they've lived here. Over the next 10 days, there's an extra, compared to normal, 2 to 4 inches of rain coming through here. Note that even though you see a drier signal from Mato Grosso, where they're trying to harvest a crop right now, they're still expecting 1 to 2 inches of rain in this area. And even though there is drier conditions coming through Argentina, there are still expected to be storms this weekend into early next week that are going to come through here as well. And what's most important is what the temperature pattern is going to do. So if I put it on a 1 week kind of outlook, for most of the next few days, it's still quite hot. But watch how quickly the heat fades as we look out there beyond into mid-February, late February. So we're not seeing the sustained high heat, even though it could be drier after the rain comes through this weekend. The net effect of what I just told you is South America's weather patterns right now are very favorable for all of their crops in most locations. Okay, thank you so much for your attention again tonight. Hope you found this informative. We'll talk again for those of you that get the report in the morning. If not, I'll talk to you again on Monday evening. Thanks.